Uh, Hello, everyone. We are Team 4, and we decided to go ahead with the global outbound and inbound travel data for the project for this course. And allow me to introduce our team. I'm Raksha. Along with me, I have Julie, Drishti, and Ashwin. We did experiment a lot with different Azure applications and the data as part of this project. In this presentation, we will go through the architecture diagram, ERD, the implementation using various Azure tools, and the visualization that we have done using Power BI. We initially thought to go ahead with just Power BI, but then we came up with some good visualizations using Tableau as well. So we plan to share that as well with you during the course of this presentation. The objectives of this whole project were to analyze different trends in inbound and outbound tourisms across different countries, mainly in US, and identify how seasonal variations affect the tourism data. Also, how what is the impact of economic indicators on from tourism? Like we do get a lot of revenue generated through the tourists coming in the country, and we did try to forecast a bit on how the future tourism trends will look like. Going deep into the our architecture diagram, this is our overall architecture diagram. We had our source data in CSV format, which we have ingested using Azure Logic Apps into blob storage, and then used Azure Data Factory and Databricks with PySpark code to clean the data, process it, and then load the data into Cosmos DB, document data model, and graph data model, and then use Power BI and Tableau for visualization. Coming to the entity relationship diagram, we have document data model and graph data model. Document data model consists aggregated data, which is mostly the counts of how the data has been distributed across various factors such as visa types, age groups, and mode of transportations. And in our graph data model, we have five important parameters such as tourist, transport mode, country, visa, and we have seen relationships between them. Like for a country, it can offer different modes of transports and different visa types. So this is our overall entity relationship diagram. Talking about in depth of how the document data is looking like in our database, it is like this. I have taken example of United States. So we have aggregated the data on a monthly basis. So for each month of each year, we have data spread out across different states for a particular country. In this case, United States. As you can see, we have the total arrivals, and which is further categorized into different age groups, transportation modes, travel types, which is inbound and outbound travel, and different visa types such as business, pleasure, and student visa. Uh, Coming to the graph data model, we have data in our Cosmos DB graph data model. Here you can see the relationship that we have. For example, we have different tourists in this case who are visiting United States. We have tourist IDs using which we have linked them to the destination country. And for example, like here we can see US offers different type of visas and different modes of transport, road for the neighboring countries and air travel for the countries which are far. So this is how the data looks like in our graph data model. I'll hand it over to Julie to take forward on the implementation.
Thank you so much, Raksha. The implementation follows the architecture diagram that we submitted in our part 2. We created a resource group for our teamwork, and the process started with staging the data present in the OneDrive file location in a CSV format. Uh, uh, to moving it to the blob storage using Azure Logic apps. Then to streamline this data from OneDrive to blob storage, we use like Logic app trigger. When a file is created in OneDrive, it copies the file to an Azure blob storage. We also used Databricks for transformation cleaning and loading, and ADF for automating the refresh of the notebook, and DocumentDB and GraphDB to load the data into a storage location. Can you move to the next slide? Can you move to the next slide? Yeah, so this is our Logic app flow. Here you can see that when the file is created at the location, OneDrive location, it triggers, and the file is pushed to blob location in our Azure account. Move to the next slide. Then we have this here you can see the automation of the trigger, the configuration for every day it will check the OneDrive location for a new file loaded at the location. Can you move to the next slide? And here you can see the Azure blob container where all the files are dumped. Can you move to the next? Yeah. Coming to the Databricks part, we have created a mount storage in Databricks. The code is written in the Python Spark framework, PySpark framework. Once the mount is created, we connected with Azure Blob Storage and just import a data from a blob storage. And then do the cleaning and transformation. We have checked on null values, the correction of the data types, as well as done some transformations with date or applied regex to remove any special character in the spelling where it was not necessary. Can you move to the next slide? Yeah, here you can see I've written function to group the age. Similarly, we have written some of the functions and done some transformation, added few more columns with and features. We have transformed different current types of currencies into USD, and then can you move back to the database? Yeah. Along with that, we once we have all the transformation and cleaning done, we have converted that data frame into a JSON document, and this JSON document is dumped into a Azure Cosmos document DB. Similarly, this data frame from this same clean data frame, we created our vertices and edges, and loaded it into a graph database or Azure Cosmos graph database using the same script. Moving ahead. We use Azure Data Factory to schedule a refresh for this notebook. And this data refresh is scheduled to run on the weekdays, and it starts at 11:30 a.m. Can you move to the, you can see the ADF pipeline on the date of 9th of April was triggered, and it started at 11:30 a.m. It took around 10 minutes, and the load of the new data was succeeded. I will, for the further part of visualization and analysis, Drishti and Ashwin has taken over that. I will pass it on to Drishti to explain further.
Thank you so much, Julie. As Raksha and Julie have spoken about the tourisms and the architecture diagrams that we've done, we used both the aggregated data in the document DB and the graph DB to come up with these next few visualizations that you'll see. Starting with the outbound tourism in United States, we see that for the year of 2023, we've seen a total of 9.56K tourists coming in. Um, the map looks over all the countries that are visited. We also see that the outbound tourism peaks in the months of November, December, and Jan, which is a very well-known holiday seasons. France, as you can see, is the most visited country by the citizens of United States. Next, Ashwin will take us and tell us about the more insights that we found about the outbound.
Yeah. So on the outbound, so we have an outbound monthly trend plotted. We could see that in January, December, followed by February, March, there is a small decline, and overall, it is up to 0.1K population traveling outbound from US. And the trends you could see that most of the population is moving to France and also Dominican Republic and Canada following. And the purpose of the travel has been identified as been pleasure and business, and hardly any students going to any other countries from US. And most popular destinations have been France and Dominican Republic and Canada. That's also in the pie chart. And it could also talk about the other percentages of population, and followed by the expenditure that US, or say the US citizens are putting out to the rest of the world. From the map that we could see that it is mostly been spent in France and Japan. The expenditure is out there, and the duration of stay is average on 50 days globally. And the population moving per month is always on the higher side when in January and February, and also followed by November and December during the cold seasons. Yeah, next slide.
Now we look at the inbound tourism that United States has. We see a tremendous difference between the outbound and inbound, with the total tourists coming in at 20,000 K. We see that there is a significant peak in the month of August and September, which is contributed by the influx of students coming in for their either undergrad studies or their graduate studies. Then we see a decline in them, and then they stay pretty much consistent throughout the rest of the months. We also see that we have more tourists that stay overnight rather than the same day exits, which are mostly contributed by the tourists that have business visas and come into US for business purposes. We also see that India leads with the number of tourists coming in, followed by Canada and China. And with the map, we see there is no surprise that the most visited states in the United States are California, New York, Florida, and Texas. Next, Ashwin will tell us more about the insights that we found.
So as we look at the inbound traffic to US, as we already seen, India stands first. And if we break down that, it's mostly the students that are coming in, and very few for pleasure and business. And the age distribution of people coming in is between 18 to 30, mostly students, and a few population coming in at 46 to 60 and 60 plus. And also we could see the inbound trend per month, and also there is a projection that we would see that it's going to increase in 2025, as that we have only data for 2023 and 2024. This is what that we currently see. As we get more data and we would have more data points, then we could estimate it to the best possible. And with that, we could also see that the money incoming to US is around $300.78 million overall for 2023 and 2024. And the spend has also tend to increase in 2025. And the change in arrival by country over time, we could see that it is mostly in August that we have countries, people from other countries are traveling to US. Yeah, and the next slide. So here I wanted to also mention that we also wanted to present a visualization summary, so that with the right access and the right people handling this data. So with any information set can visualize the overall travel history of any individual with their passport number or their details, and also the institution that they're traveling to, and the reason and the degree type that they have. Yeah. And with this, we could say that we have met all our criteria for the project in terms of visualization and the requirement, mainly about comprehensive overall US inbound outbound travel data, and integration of diverse data sources, in-depth analysis, and user-friendly design with interactive search filters and visualizations, and use of historical data for forecasting future travel and trends. Yeah.
Next, we've also done some graph visualizations for the graph data model. We start with a specific tourist, and we're trying to find out all the details about the tourist. We can find out what, sorry, we can find out what transport mode they've used, what visa they're holding, which country they're traveling, and which country they belong to. Next, we're looking at three different countries, which is Canada, Taiwan, and South Korea. We're trying to find out which tourists come in, and if we were to select on any one of the tourists, we will be able to see all the other details as their transport, their visa, and their what country they're coming in from. Next, we say we're trying to localize which tourists and where they come from use the road transport mode. And we found out that Canada, which is one of the neighboring countries, is the one where frequently road is used as a transport mode to travel to United States. Next, also, we're trying to localize the business visa holders that are coming into United States. We're trying to find what transport mode they use, which country they're coming in from, and how long they're staying in. This is it from our end, and we're open to questions. Please feel free to ask us.
I have a question. In your Azure portal there, can you move on to your Azure portal for the Cosmos DB Gremlin API? Yeah, so here there are some different graphs like graph 1, 2, 3, 4. So, what's the difference between all of these graphs? Like, do these have different kind of data
So,
or is it?
when we started loading the data, we started to process in small amounts so that we see that when we are loading the data, everything is fine or not. So that's why we faced some issues with respect to the partitioning key and all. So the final data that we have loaded is in the graph 4. It was just a historical progression that we made across different graphs that you see over here.
Okay, thank you.
Any other question or comment for Team 4? Okay, so Team 4, your team did a lot on the project. That's excellent. And also your reporting and visualizations were great. Okay, we want to make sure we recognize what you have accomplished on the project. Could you go back to your architecture diagram?
Sure, Professor.
Okay, so for visualizations and the reporting, you included a G.V. Could you show us what visualizations were created using G.V? Or all the graph visualizations, or just some of them, or give us some examples, please. Or did you use G.V?
Yes, Professor, we did use G.V to create the graph model database visualization. They were the ones which were at the end. Raksha, can you move to these ones? Yes.
Okay.
So, Professor, these are the 4
Queries that we
we have.
wrote done for, using G.V.
Excellent. Okay, great. Okay, great work. And presentation, again, I want to recognize what you have accomplished on the project. So your team did a lot on the project, especially your analytics was wonderful.
Thank you, Professor.
Yeah.
Thank you,
Thank you.
everyone.
Yeah, thank you, Team 4.